Hello, my lovely students. So here we are finishing out section 3.5. We see here, these are the four other guys as I think of them in terms of trig functions and their derivatives. And again, I really do recommend trying proving that the derivative of tangent is secant squared. Like do the derivative with the quotient rule of sine over cosine. Work through it. That'll give you good practice with your sine and cosine derivatives and with your tangent and your quotient rule. All right. But this guy here, we have -3 minus 2 times secant x. And then there's like parentheses around the x and then close. So that's a thing times sine of x. So we have overall a product here. So remember our product rule. If f of x is a times b, then f prime of x is a prime times b plus, and then here you can either write it a b prime or b prime a, like the order you do it in is whatever. Because you're going to have the thing and its derivative, and then the other thing and its derivative, and you just got to make sure it's not derivatives together. All right, so looking at our thing here, a is -3 minus 2 secant x. So we want to figure out what is a prime. So the derivative of -3 not being multiplied to anything, this is just a constant. Constants are flat line functions. Slope of a flat line is 0. So I'm going to write the 0 here, but when we carry it over to solving, we're not even going to bother writing it. -2 times 2 is a constant. It is a -2. So we're going to have -2 times, and now we're going to do the derivative of secant, which, nice little hint right above there. The derivative of secant is secant tangent. So secant x times tangent x. You need to write the x's. If you write a trig function without an input, it's like you're writing a square root without a number under it. All right, now let's take a look at our b, which is not so bad at all, just sine x. So then our b prime. So sine at 0 has a slope of 1. The trig function that starts at 1 is cosine. So that is how I reason through if I haven't done my sine cosine derivatives in a while, is I think about the graph of 1. What's the slope there? Who has that point there? And it's always like wherever my 0 is, because that's how I remember how the graphs, that's where I start. All right, so our dy dx using our product rule. So it was a prime. So that is -2 secant x tangent x times b, which is sine x. All right, there. Now we have more room. Plus, so that was a prime, so now I need a. -3 minus 2 secant x times b prime, which is cosine. Now, like I said before, a lot of these, we don't bother cleaning it up. we leave it as is. But just for the sake of, in case you had to, and to remind you of how some of the trig simplifications work, I'm going to go ahead and go through it. So this guy here is now 3 things being multiplied. So if we had to do a second derivative, we'd want to clean this up first. And generally, if you have to do something with your derivative, cleaning up is just, well, the nice thing to do. All right, so the -2 is just going to be there. But secant is 1 over cosine. Tangent is sine over cosine. And then sine is just sine. Now this other part, a little uglier. Because now we've got a cosine, but this is a 2-term thing. So this cosine is going to have to get distributed to both parts. So let me once again remove our kind of scratch work. I shouldn't say remove, I should say move. So this would be -3 cosine x, and then -2 secant cosine. Now remember, the secant is 1 over cosine, though. So now, a little more on the cleanup. So our dy dx is -2. Now when I look, the top is 1 times sine, the bottom is cosine times cosine. So that's sine squared over cosine squared. So sine over cosine is just tangent. So squaring the top and the bottom, it's just tangent squared. -3 cosine x, that's all we can do with that. But over here, the 1 over cosine times cosine does indeed cancel out. So over here, it is just -2. Now, if we didn't realize that and we like worked through the product rule derivative here, whatever we get would like balance out and cancel out if we did the derivative of it. It'd just take us a lot of work to get there. So that is our simplified derivative. But there's absolutely nothing wrong with the initial one. And in fact, the first one is easier to grade. So the last one may look prettier, but the first one I can clearly see, all right, there was the prime of your first one. There's your second one. There's your first one. There's the prime of your second one. Yes. All right. And now we come down here, and this one, y is cosecant x, like, cool, nice, small little thing. And then what? Y double prime. So we just did the derivative of secant, which was secant tangent. So remember, cosecant is going to follow secant's pattern, but our cosecant and cotangent do everything with cos. So not cosine, but with cosecant and cotangent following the tangent secant pattern. So our derivative of cosecant, sorry, will be cosecant times cotangent, but it's negative. So now the second derivative. All right, now we have a product. So we've got an A and a B. So if I keep A, negative cosecant x, and remember, any of these patterns, product rule or quotient rule, parentheses. Write them more than you think you really need to, and then you should be covered. Because a lot of people will forget to write them, and you want to get in the habit of writing them. Even if you understand what it's going to mean, it's better just to have it there to be very clear about what's grouped and what's not. So there's our A. So B, cotangent. The derivative of tangent is secant squared. So the derivative of cotangent is cosecant squared, but with a negative. All right, so we kept A, so now we're going to do the derivative of A, which is literally what we just had for y prime because it's cosecant again, but it's with a negative. So we're going to have the -1 that's part of A, that's carrying through, times the derivative of cosecant, which is negative cosecant cotangent. Now all of that's still just A prime though, times B is just cotangent. So a lot going on here. Like I said, this is the easiest to grade, but WebWork loves to be like, I hate you, give me something else. So here, negative times negative, at the very least, like we can clean up the signs because that's just a little bit of work. So negative times negative is positive, and then cosecant times cosecant squared, well, that's just 3 of them being multiplied. So cosecant cubed x. And then here I have that -1 that came from A and the negative that came from the derivative. Those are positive. And then I have cosecant cosecant of x times cotangent squared of x. Now, the back of your brain might be giving you a little niggle of a reminder, like, isn't there something with cosecant squared and cotangent squared? There is. And those other guys come from this one. So we know sine squared plus cosine squared equals 1. If I take that and divide everything by cosine squared, I will get tangent squared, because sine over cosine is tangent, plus cosine squared over cosine squared is 1. And then over here, 1 over cosine squared is secant squared. So then if I go back to my original equation, and instead of dividing by cosine, I divide by sine, I get 1 plus cosine over sine is cotangent, and 1 over sine squared is cosecant squared. So if we ever get 1 plus cotangent squared, that's the same as cosecant squared. What we are most likely to see, though, is cosecant squared -1 or secant squared -1. Those guys will sometimes creep up, and seeing that they're tangent squared or cotangent squared can be a little weird. Doesn't happen too often. Like we don't often do multiple derivatives of trig functions, but it's not impossible. Like I could certainly see it for some weird applications that I'm not totally sure of. All right, so we found our first just using the formula, and then our second derivative required product rule and remembering several formulas. So I put the 1 plus cotangent squared equals cosecant squared over here. Both of these terms do have a cosecant, but I'd end up with cosecant squared plus cotangent squared, which is not what we have here. If it was 1 plus cotangent squared, I'd say, yeah, make the substitution, but cosecant squared plus cotangent squared isn't one of those, so meh, we're good. And then our summary here, there's all 6 of the trig derivatives. I know it sounds silly, but it is actually worth it to hand write your formula sheet because it'll activate more parts of your brain than just taking pictures and putting them together. I know it's tedious extra work, but it does stick better in your head. You don't have to write it on paper. You could write it digital, save a tree. But you're also in a math class, so you can also save trees by recycling at the end of the course. All right, that's all I got for 3.5. See you guys for 3.6 on Wednesday.